Good morning. So what I'm going to videotape is our personal finance. So for personal finance, everybody, you can have a composition book or a spiral notebook. I like using spiral notebooks. We do take notes for this class. They're very useful. They're going to help you on the assignments, on the reviews. So you want to make sure that you're taking notes. For personal finance, where the first chapter is chapter 2. It's called Modeling a Business. So it's all about it is all about economics. You're going to see it overlap from your economics class, but it's from a consumer point of view. So we take a different point of view on it. Okay, see what we're looking. Okay, so this one, so this is all about scatterplots. So it's about interpreting scatterplots. So we're looking at data, which we do all the time. I'm going to put it, okay, so in our central question, everybody, so we do our focus note format. So how can scatter plots display trends and data? And so data, we're always looking for patterns in data all the time. And as we're using our phone, data is being collected all the time about what apps we use, just everything that we're doing. And when we go to the grocery store, data is being collected. Okay, so what is correlation? So correlation is an association So it's an association between two variables. So if a store owner is just collecting the number of t-shirts sold, then that would be univariate data, so just one. But if he's collecting how many t-shirts are sold in like the days of the week or time of the year, okay, that's considered bivariate data, like bicycles, so bivariate data. Okay, so he's looking at two different things. So that would be causation. So if the explanatory causes a change in the responsive variable, okay, that's a causal relationship, they call it. So it causes it to change. Okay, so with this, everybody, so if it's a positive relationship, okay, so that means that both the explanatory and the responsive variable increase. And you all are going to notice that I do use color. Color helps our brain organize the information. So you want to use color. Okay. So we have our X and our Y axis, everybody. So so if it helps you think about it, so dry, mix. So M, or we use E for explanatory. Okay. And so notice, everybody, that's going to give you a positive slope. We can also have a negative correlation. So negative correlation is going to be if one value increases, the other value is going to decrease. So if the explanatory value increases, the responsive variable decreases. Okay, so that would be an example if we have like a negative slope. It's going Going down, it's going timber. You better move, you better run. Okay, so it's a negative slope. Focus on what I'm writing, so singing. Okay, so that's going to be a negative slope. Okay, we can also have where there's no correlation at all. So sometimes, so for no correlation, when we graph the data, okay, it's going to look like this. And then it's going to look like that. Okay, so all over the place, so no correlation, so there's no trend. So when you graph it, it would look like that, okay? Of course, we can also just look at the data table too. It's totally up to you what works better, okay? Okay, so what is a causal relationship? So everybody, we're looking at these, okay? So what a causal relationship means is when the explanatory variable or the independent variable causes a change in another variable. So when one variable causes a change in another variable. So the independent variable causes a change in the dependent. So you see up here the dry mix. Okay, so that I and D. And then with the dry mix, everybody, so Y, dependent variable, the responsive variable is on the y-axis. And the explanatory variable, independent variable, are on the x-axis. Okay. So change in the other variable. So it causes it to change. So what is causal relationship? So see, it has that word cause in it. Okay, so it's going to cause it to change. Okay, so I've already been talking about those terms. Okay, so we have our two terms that we're using. So we have independent. Let's say different color. Okay, so for explanatory, that's our independent variable. Okay, our x value, it's also the input, and it causes the change in the responsive variable. Okay, so it's called explanatory, and this is the terms that our financial algebra book use. Okay, so that's also, like we said, so it causes the responsive variable, or the dependent, which is the output, and our y value, so it's going to be on the y-axis. And it's the one it's the variable that's affected by the change. Okay, so it's affected by the change in the explanatory variable, those values. Okay, so let's look at some examples, everybody. So one example that we have is the number of days. That you work and the amount of money that you earn. Okay, so amount of days work is explanatory. And the amount that you earn is responsive. So the more days that you work, normally, unless you're working like 18-hour days. Anyways, so it's going to increase, or just time in general. So more you work, the more money you're going to earn. Okay. And I wanted you to notice that for all of ours, we're pretty much, we're starting with 0. Okay. So we always start here at 0. It's going to be 0, 0. We're talking about money. Okay, so for this one, so the other example is if we're looking at temperature, everybody. Okay. So think about here in Arizona. So we have temperature and the number of sweaters sold. Okay, so that's going to be, so the temperature is going to be our explanatory variable. So if you think about it, everybody, so that's what's changing. And so if we start here, everybody, at 100 degrees, right, we're going to sell more sweaters. So if we start this one right here at 40, you're going to sell more sweaters when it's cold than when it's 100 degrees. Okay. So the number of sweaters sold is our responsive variable. Okay. I was going to do one more example. So the more that you study, okay. So time, okay. So your grades on a test is going to be the explanatory variable. Actually, responsive. Paying attention, responsive. Okay, so your grades on the test, so percent that you get, and then our number of hours that you study. You did focus studying is your explanatory. So that would be, everybody, another positive trend example. Sorry. I have to leave that part at the bottom, everybody, so I know that it's still recording. Okay, so second page. I'm using these felt pens, so I don't write on the back, because on the back you can see the paper, so, but you can definitely write on the back. So everybody, you can just do your notes with colored pencils too. Those work too. I use the felt pens just because it's a little bit brighter, because I want it to show up for you all to see. Just makes it a little bit brighter. So we're still on section 1. Okay, so I'm going to show you using decimals. If you have a graphing calculator, you can use that too, and you can ask me for the steps. So what we're going to be using is decimals.com/calculator. Okay, so the steps that we're going to use for this. So you're going to go plus to create a table. Okay, and you're going to input your X and Y values. So we're going to put those values in. Okay, and then you're going to click on, there's an F of X button. So down below it, so it'll be below it. So you click on this, and then you're going to use use the Desmos keyboard, everybody. So you'll see it at the bottom. I'll show you. And you're going to do Y, MX plus B, and you want to use that symbol, okay? And then you're also going to go to see the graphs, everybody. I think it looks like a little wrench. So don't let it throw a wrench into your graphing, because we can see the graphs, everybody. So you're going to change your X and Y values. Okay, so you're going to change your minimums and your maximums. Okay, and pretty much for this class, everybody, our minimums are going to be 0. I'm drawing the line through it so you know that that's a 0. Okay, so we are going to look at some data. Okay, so this is so Marie has a concession stand. So Maria does, and she is looking at. So she's recording the temperature and the number of water bottles that she's selling. So she's wondering if there's a causal relationship between the number of water bottles that she's selling and the temperature. So I'm writing these all down, and we're going to put these into decimals, everybody. Sorry, this is 100. I'm going to rewrite it, everybody. So this one's 100. We have to have 100-degree. We live in the Sonoran Desert. Okay. So everybody, so with this, I just want you to notice, so it's the temperature and then number of water bottles. Okay. So our y value is number of water bottles, x value is the temperature. And Maria wants to know, is there, okay, this is example 1 in our book for 2.1, is there a causal relationship between the number of water bottles that have been sold and the daily temperature? Okay. So we're going to go to decimals, everybody. So let me split my screen. So normally I do when I split our screen. So everybody, so we're going to decimals. I'm going to go to decimals calculator because we're doing the graphing one. So you're going to go on plus. You're going to add a table. Okay, and we're just going to put those values in. So just put them all in. 135. When it is 79 degrees. And everybody do this along with me just to make sure that you're getting this. You got those steps. That's one the more we do it, better we'll get at it. Okay, and then when it's 86 degrees, she sells 91. And then the next day was also 86 degrees. She sold 207. And then it jumped to 91 degrees. She sold 235. And it was 95 degrees. Maria sold 237. And it's 100 degrees. Maria sold 243. Okay. And then you click here. You want to do expression. This is where you're going to go to keyboard. You're going to do Y. The part I need. You want this, the little wavy, and then X, back to here, plus B, I'm going to double check that. Steps. Oh, we have to do the 1. Sorry, but I forgot that step. Y, 1, X, 1. Okay. And then it'll give you the value. So we need to add that in. We'll show you adding that back into our notes. Okay, but now it gives us our equation, everybody. So this is our slope. This is our y-intercept. Okay, so if I was to write that equation down, it's going to be y is equal to 4.72. So 4 72/100 x minus 213, and we're going to round to the hundredths place. So it's going to be 3. So minus 213 and 31/100. Okay, so really we look at that number 5 and I've rounded up. Okay, now we're going to go. I'm going to make the keyboard go down. We're going to go up here to the French. So for our settings, so I'm going to go back up here to the table. So we look at our minimums and maximums. So I'm going to use 0. You could also use for our x-axis, we could actually use like 65. And then for our highest value, I'm going to use 110. So you always want to go like a little bit over. This one to 60. And then this one we start out at 102. I'm going to go 100. And this one goes up to 243, so I'm going to do 250. And everybody, the reason I want to do that is just so you can actually see the graph. So if you see how you graph, and this line is called the line of best fit. So this is showing a positive trend. Okay. So we'll definitely be using this in the next section too. We'll just keep working on it. So we're going to sketch the graph. So just do a sketch in your notes. Okay, and then this is going up by on the y-axis. So it goes 100, then it goes 150, then it goes to 200, and it goes to 250. So we have temperature versus the water bottle. And then we have our line of best fit on there, everybody. Okay, so see here, and then we just have our line going up like that. Okay, so the line of best fit is just as close as it can get. So also everybody change that part. So you do need to put in a 1 with this. I'll rewrite it so it's going to be y1, a little wavy, mx1 plus b. Okay, so using the decimals keyboard. Okay, you got that, everybody. So let's go ahead